next we will see the concept of standard continuous time signals. What will be the standard continuous time signals and their graphical representations and some mathematical representation for this standard continuous time signals. After completing his standard continuous time signals, move on to the standard discrete time signals. There will be not much of difference between the standard continuous time signals as well as the discrete time signals. Let's move on to the next concept. The first basic standard continuous time signal, that will be the impulse signal. That will be the impulse signal. So in this standard continuous time signals, we will be represented in graphical representation. Graphical representation and mathematical derivation for this impulse signal. Let's see the graph for this impulse signal. This will be look like this. This will be then infinite, and this impulse signal, the representation is as del of t. So here one thing you have to observe, at 0 time you will get an infinite output, and remaining cases that will be a 0, right? So here if you want to represent it, that will be a del of t, that will be equal to infinite. At time t, that will be equal to 0 case, and next del of t, that will be equal to 0 for remaining cases. This will be said to be an ideal impulse signal. Ideal impulse signal. Why we can tell this as an ideal impulse signal means, for example, if you see at 0 instant of time you will get an infinite output. That will be not possible in the real time. We can't find the area or the power for the infinite signal. If you want to find some area or the power or energy for the required signal, that signal must be in some bounded signal. Then only you have to find something. Either not, you can't do anything. But the one beautiful thing about this impulse signal be that without this impulse signal there will be no world. All of the electrical engineering, that will be basic term or basic terminology will be started with this impulse signal only. And next, and here you can observe at a single instant, at 0 time you will get the infinite output. That will be not possible. So in that way we can choose another method, that will be the unit impulse signal. We have to bounded ourselves to the infinite value to some finite value, and this instance to the some negligible small amount, right? Next we will see the what is meant by unit impulse signal. Unit impulse signal. So here the representation will be like this. The representation be the this will be the 0, this will be the plus a by 2 and minus a by 2, and I can't take as an infinite, I will be taken as some finite value, taken as small finite value, that will be taken as some k. So one thing I have to tell you, for the impulse signal, area under the impulse, that will be equal to 1. Area under impulse signal, that will be equal to 1. So here area means whenever you see the area, then defaultly you put the integration. Area means integration. Whenever you see the differentiation, differentiation means slope, finding the slope. Whenever you see the differentiation, that means you just like in slope, to find out the slope. And here area under the impulse signal, that will be equal to 1. So this will be the B minus A, that will be equal to A divided by 2 minus of minus A divided by 2. That will be equal to A divided by 2 plus A divided by 2. This will be the 2A divided by 2. This will be equal to A. So here how much you will get? You will get an A. And you can clearly observe here one thing. This will be just like a rectangle, right? Small rectangle. We have to find the small rectangle area. How much you will get? You will get the, so here area of impulse signal, that will be equal to 1. And if you want to represent it as minus infinite to infinite del of t into dt, that will be equal to 1. And here same, I will be represented here. Area means integration, right? Minus infinite to infinite del of t into dt, that will be equal to 1. And from this representation, unit impulse means 1, right? Unit means 1. And here the representation be like this: del of t, that will be equal to 1 for t equal to 0, and del of t, that will be equal to 0 for t not equal to 0, and simply represented with this del of t with 1. So what will happen? So this will be become the 1, and area of, and here you can observe this will be just like in a small rectangle, right? Rectangle, area of the rectangle, that will be then L into B, L cross B, that will be equal to 1. So here length, how much? You will get an A cross, and breadth be the K, that will be equal to 1. And here you can see K is equal to 1 divided by A. So now you can substitute this unit impulse signal, and you can use it in a very fruitful manner. In almost every research laboratory, we can use this unit impulse signal very well. Okay. This was the main concept behind this impulse signal as well as an unit impulse signal. Here one thing you can write, this will be an instant of time, at 0 instant or quick instant. At quick instant you will get an infinite value, right? Next we will see the what will be an unit step signal as well as in step signal, and what will be the properties for the step signal. Thank you.